Hey, Chris Matthew here. I've been experimenting quite a bit lately with decentralized distributed edge computing capabilities for computes. And I've experimented a lot with blockchain, Ethereum, smart contracts, as well as IPFS. And I'm going down the road of IPFS because my results of using the blockchain don't allow me to accomplish the supercomputing use cases that I'm chasing. So for a couple of reasons. One, it's very difficult to isolate the actual cores on a blockchain. You end up getting a lot of cores or computing resources working on the same action and then proof of work all related to the same effort. So you have a lot of wasted computational resources. And then what I've also found is that reading and writing to the blockchain is also very latent. Reads are fairly quick. Writes I've seen can take as long as like 8 minutes to write and distribute across the blockchain. And that really limits the real-time nature of what we're trying to accomplish in this supercomputer aspect. But IPFS, on the other hand, they have a new pub sub capability that does allow you to do real-time messaging, kind of like MQTT would do in the IoT world, and was able to easily restructure the computes.io infrastructure to allow kernels and cores to basically work as a swarm, if you will, just purely using IPFS pub sub, and cores can still request work. You'll see that they can say, hey, I'm available every minute. When the kernel has work for the cores to do, the kernel can communicate with the core in more of a peer-to-peer fashion, private, even encrypted peer-to-peer fashion, where it can send it either JavaScript in string, like we've always done, or a URL of JavaScript, or even a node module to run along with the data. And the data can also be even an IPFS hash to reference as well. Once the core completes the work, it responds with the result, and the kernel gets the event. So very similar to the same programming that we've done to date with computes.io. In fact, we start it the same way. So you start domain key and then npm start, and the domain key, if you recall, that's a way of ensuring that only your computes are working on your work, and you can create different domain keys for different projects or departments within your company, etc. So let's go ahead and start this core up. We'll see here that as soon as it starts, it shows that it's listening for work on this domain key that we were just talking about. There we go. And then you'll also see it connects to the swarm, and it has a public-private key, and then you can also see its node ID there. So it's a unique node ID for this particular core. And then every second, as you can see, it's requesting work, and it's saying its status is available. So let's show you real quickly what a kernel looks like. Very similar to computes.io in the cloud, except I've created a new computes-IPFS node module. Here in this example, we're going to pass it just a JavaScript function that takes some data and returns the data. Again, that's the domain key we're using that the core is listening to. When we connect to the IPFS swarm, we're going to get an onReady event. That onReady just basically will output that we're connected to via IPFS. And then for fun, I'm just going to send 3 parallel operations with the data incrementing 0, 1, and 2, along with that JavaScript string. And then you'll see on result, this is when the core returns the result. I'm just going to count when I reach 3 results. I'm going to disconnect from the supercomputer. So let's go ahead and run that. See, our core is still working, so I'm going to say node index. That's this kernel here. If we look at the cores again, we'll see them start taking on the work. And since I only have one, it'll be singular. There it is. So JavaScript operation detected, result is 0, result is 1, and result is 2. We go back onto this side, we'll see that the results came back, result 1, result or 0, 1, and 2, and then it disconnected at the very end there. So there you go, fully decentralized, fully distributed computes.io option that's available to start experimenting with today. And it can run locally, globally, with or without cloud infrastructure, and truly decentralized and truly distributed. Stay tuned for more details.